Okay, this is just a real short, couple-minute video on position versus time graphs. So there'll be another one on velocity versus time graphs, and then there'll be a third one on acceleration versus time graphs. Really, the first two are the more important ones, position and velocity, because most of the things we're going to do in here involve constant acceleration. So graphing it, you basically will get horizontal lines most of the time. But for right now, let's focus on the other two, which are position versus time, and then in a second video we'll have a velocity versus time graph. Okay? So if you look up here, you'll see that there is a position versus time graph that is labeled properly. It's got a y versus x title on it. All right, position versus time. You don't necessarily have to have this prepositional phrase at the end of a rabbit. You can, but the more important is that you have the y versus x as your main part of your title. When you look at the y-axis, you see that it's labeled in equal increments, okay, and it's got a label with units, position in miles. The x-axis, very similar, has equal increments and also has label with units, time and hours. So we're looking at the acceleration, the position of a rabbit over the course of 5 hours, okay, changing its position in miles. All right. Now, if you look at it, you can tell that there are really three distinctive parts to this graph. There's a curve, then there's a diagonal, and then there's a separate downward sloping diagonal. Okay, so what really do those mean? Okay, now the things you have to understand are the basics of a graph, or any graph, is first the slope. What does that mean? What the y-intercept means. Okay, and then also, what does going below the x-axis mean? So how does the x-axis affect position versus time graph? Those are the big ones. All right? Now, the slope of a position graph, you remember from algebra class, slope is rise over run. Okay, so this is rise over run. Or sometimes it's also called the change in y over the change in x. You see that you have the change in position over the change in time. That's the definition of velocity. Okay, so the slope of a position graph represents the velocity of the object. Okay, now in this case, we're only talking about the rabbit moving in one dimension, east-west or north-south. Okay, it doesn't specify which one, so you can't tell based on the graph, but you should be able to recognize that this is all one-dimensional. Okay, he's running in some kind of tube, let's think of it that way. He's in a long pipe or something. All right, now, so the slope of this line is going to represent the velocity of the rabbit at different places. So you can find the velocity at any point within those 5 hours if you're able to find the slope at that instance. All right? So if we look at this, the first 2 seconds, the slope is not constant. The slope at 1 hour, okay, is not as steep or not as positive as the slope at 1.6 hours, let's say. All right? See how the slope is gradually increasing? If the slope is increasing, the velocity is increasing. So the velocity is changing, and that's the definition of acceleration. Okay, so when you see a curve on a position graph, the object has a non-zero acceleration. Okay, so that goes along with the first 2 hours. So the first 2 hours, okay, the rabbit is not moving at a constant velocity. It's accelerating, and you can tell because you can see how the slope of it changes. So what you can do is, if I said, or on the IB test they say, what's the velocity at 1.5 hours, which is right around here, let's say. You could just take a small snapshot of that line and find the slope of it, and that will tell you what the velocity is right there. And the smaller your increment is, the better your estimate's going to be. If you take a large increment, like all the first 2 hours, you're going to find a very average value for your velocity. The smaller the pieces get, the more exact you are. And that ties into things you'll do in calculus and HL math and so on. All right. Now what's different about the first 2 hours as opposed to the next hour from 2 to 3 hours is you see that there's no change in the slope. That's a very constant slope. Okay. So that means that this portion from here to here is constant velocity. Okay, because we have no change in the slope. Now what's different about this one as opposed to the next 2 hours is one, the slope's not the same amount. Okay, this one's steeper, but it's constant. So this one, from the last 2 hours of the rabbit's movement, you can see that the rabbit moved at a constant velocity, okay, because you can see that there's no change in the slope. It's a very nice straight line, all right? But what you do notice is that it's downward this time as this one is upward. So this one is a positive constant velocity, and this one is a negative constant velocity. Okay, so what does that mean for you? The initial position of the rabbit was 0, 0, whatever you decided the origin to be along its motion. It accelerated away, or in the positive direction, okay, accelerated positively away from the origin, then moved at constant velocity still away from the origin, and then came back towards the origin. And you can also tell that based on where your increments are. See how it's all these numbers up until here are positive. So 1 second it was 2 miles away, 10 miles away, 20 miles away. And then it was 30 miles away. So it's still moving that direction even though it's changing its acceleration. Then once you get to this negative slope, you can see at 4 hours it was 2 miles away from where it started. Okay, and then around 4¼ hours, roughly, I'm just estimating that, it's back to where it started, and then it actually started to move on the other side of its origin. So if you can envision a rabbit moving in a pipe, all right, okay, here's the rabbit, on the other way. If this is where the rabbit started, that's its origin. It moved away from the positive direction the first 4.25 hours, I'm sorry, for the first 3 hours, because that's my peak. And then in about 3 hours it turned around, got back to the origin at about 4.25 hours, and then moved in the negative direction that you denoted inside the pipe. So when it was all said and done, it ended up 20 meters in the negative side of where it started. And that's what that spot means, and that's what underneath the x-axis means. It denotes position in relation to 0, 0. What do you call the 0 point? Okay. I'm going to go back real quick to the y-intercept. All right. The y-intercept would be its initial position in relation to what you're saying is the origin. Okay? So if you're calling this the 0, 0 point, and the rabbit didn't start there, it started a couple of miles away, then your graph would start up above it, or down below it if it was on the left-hand side. Okay? So you have to understand what these three mean. They're really important. If you can really get the grasp of what the slope means, I think that's the most important thing. But you do have to be able to interpret, if the IB were to ask you, what's the rabbit's position at 3.6 seconds, you should be able to estimate it just by looking at the graph. Okay? You're going to see some places where the curve isn't necessarily like this, but might curve the other way. And that's something that we can discuss together. This is just a very brief overview of what different parts parts of a position graph.